A very good morning, students. Let us look into our very next topic called three input lookup table. So, what is that we are going to design with this three input lookup table is he says which has three inputs. When any one of the input is high, output is high. So I know that I need to design a lookup table which has three inputs, and he says if any one of the input is high, output is high. So I'm going to draw the truth table for it, which has three inputs A, B, and C, and the output is termed as Y. And since there are three inputs, how many combinations? 2 to the power of 3, which is 8. So 000, 001 till 111, I'm writing the combinations, three input combinations. So what is the output? He says when any one of the input is high, output is high. If any one of the input is high, output should be high. Since there is no input high, output is 0. Any one of the input is high. Can you see C is high? So output is high. Here B is high, output is high. Here B and C is high, output is high. So here A is high, output is high. So any one of the input is high, output is high. I have drawn the truth table. Now what is that I need to design? I need to design a lookup table. From the truth table, I need to design a lookup table. So what is this lookup table? Lookup table is nothing, but if I want to design a lookup table, first I need to check number of inputs. If number of inputs in the truth table is 3, listen, if number of inputs in the truth table is 3, 2 to the power of 3, which is equal to 8, I need 8 memory elements. Okay, so these boxes are nothing but static RAM memory cells, SRAM cells. Okay, since 3 inputs, 8 SRAM cells, I need to stack one over the other. Now, the output of this truth table has to be saved in the memory. Can you see? I have 8 memory cells. Each cell can store one bit of information. So what is that data I'm storing in each cell? Whatever output I've got, 0, 1, 1, 1, 1, 1, 1, 1, all these outputs I'm storing it in the memory element. So what is a lookup table? Lookup table is nothing but a combination of SRAM cells. It is a combination of SRAM cells in which we can store the truth table. Are we not storing the truth table, output of the truth table into the memory? So this is a setup of lookup table, whereas my inputs A, B, C are connected to the address IN0, IN1 and IN2. My inputs are connected to the address. So I can say my logic inputs are connected to the address inputs. And my logic output, can you see why my logic output Y is connected to the memory? Okay, so my inputs, logic inputs are connected to the address lines. My logic output Y is connected to the memory cells. Okay, suppose I want data from 111. If my A, B, C is 111, A is 1, B is 1, C is 1. I go to the address 111. The content in that address is taken and given out as the output. Suppose I want data from 0, 1, 1. So my A will be 0, B and C will be 1 and 1. I go to 0, 1, 1 location, 0, 1, 1 location, address location, take the data which is stored in that location and send it to the output. So this is the setup of what? 3 input lookup table. So how will you construct a 3 input lookup table? That depends upon number of inputs. If inputs are 3, 2 to the power of 3, 8 memory cells are stacked one over the other. After that, the output of the truth table is stored inside the memory cells. Each cell can store 1 bit information because this memory cell type is static RAM, which can store only 1 cell in each box. Okay, 1 bit in each box. And the inputs A, B, C, I call this as logic inputs. This is logic output. Logic inputs are connected to the address lines. Logic output is connected to the memory cells. So if I give my address line 000, it goes to that address 000. Content in that memory location 000 will be taken out and sent to the output. This is a function of 3 input lookup table. And you can take any case for this truth table. Suppose a full adder is another example. Can you see? This is a full adder where you have 3 inputs and 2 outputs in this full adder, whereas first 3 inputs are acting as an address line. This is your output where you have a sum and there is one more output, carry. So each location, since 3 inputs, 8 cells. So first 8 cells is used for sum. The next 8 cells is used for carry. If my address ABC is 111, I directly go to memory location 111, send the output 1 to the sum, 1 to the carry. This can be done only if the address and address is same for sum as well as carry. This is also an example for 3 input, 2 output LUT. Okay, so this is a brief understanding for lookup tables. Thank you.